Okay, let's get started straight away. We have only an hour or so. I say topics because there's too little time to cover anything systematically. Martha Palmer and I, in 2023, in Ljubljana, Esley, taught a week. Was anyone there? A weeks-long course on UMR, and I am planning on doing a weeks-long course, hopefully for the next Esley, on just the semantics of UMR. So there's a lot of material to cover. And so we're going to talk on, we're just basically going to address a couple of issues. One, the failure of AMR to represent basic structural relationships in first-order logic, and how UMR has accommodated to solve that. I'll dive a little bit into a semantics of the UMR graph. I can't give you a full treatment of it here. If you want, we can talk about that maybe tomorrow in office hours or maybe during coffee breaks. That's the continuation-based semantics that I've developed with Ken Lay. There's also a continuation-based semantics for gesture that I'll allude to. But right now I want to talk about quantification, the scope issue, and then because it's critical for the interpretation of language and gesture and action in the kind of multimodal communication we just talked about, as well as for any type of inferential task that you would be confronted with as, let's say, a knowledge-enhanced LLM, we're going to talk about sub-events and the annotation language, generative lexicon AMR, GLAMR. Just briefly. We don't have a lot of time, but hopefully we'll get to at least just enough time to get you interested and perhaps a little bit confused. Maybe a little bit beyond that. So, all right. The first thing you see when you approach AMR, this was my familiarity, my experience, was the complete lack of any representation of not only definiteness, number, certainly tense, but the quantificational force of the argument or anything else. So you had originally this idea of a mod attribute to an arg0 role label and the notion of all that also had for everyone in the room, so it's in the room people, all the in the room people, so location for room, this is, again, just a big adjective, think of it kind of a pre-nominal sort of, let's say, kind of Turkish style, agglutinative, in the room located person, okay? And then this all. Now, the problem with this representation is what to do with all. And there isn't really a lot going on here because I could just say there's the scope over the event. So there's not a problem of an ambiguity of scope, but there's still no representation of scope. So what's scope doing?
But aren't these scopely ambiguous?
Sorry?
But isn't there everyone in the room listens to me talk? It does seem like there's some scope of ambiguity.
Okay, so yes. So here, yeah, I misspoke. Thank you for pointing that out. I was thinking it was intransitive. I wasn't even looking at the slide. I was thinking everyone in the room fell asleep. Even there is a potential ambiguity because you can have one big event of falling asleep and you can have individual distributed fallings asleep. But that's not, as we know, that's a lexical scope issue. Now, but here I have a talk. I'm challenged with these. I wish I had my own. There, that's better. Okay, so there's a talk and there's persons. Right? Right. So there's one talk. Right. So my favorite example is everyone on the flight watched a movie. Okay. I think I used this example last year at the UMR school as well. Go back to James Bond 1960 747 with what are called flight attendants, and you've got this little bitty screen in the front and everyone's watching the same movie, right? Fast forward 2025, everyone's watching a movie, it's on their device, right? So it's unlike, possibly in the screen in front of them, but it doesn't matter. There's probably going to be as many movies as there are people. But the number of movies is dependent on the people. So it's a matter of the dependency. So scope is a matter of dependency. It's a dependent variable. As a type, it's actually a dependent type. So the point here is, this is going to kill me if I don't watch it. No, don't worry, it's fine. No, it'll be entertaining to see me re-break my toe. It'll be good. And you won't be implicated at all.
I think you are more important than my laptop, that's why. Let's
That's good. Oh, we can implicate Beckham or something like that. So the point is, there are not, how many cups, how many talks, scope. There's no way to do it. So quantifier scope, you can imagine having something like an everyone as an argument. If you do have everyone actually as the value of a link, okay. You can do an interpretation. The problem is not that you can't take a graph and create an interpretation. You can do that with anything. The question is, will it be systematically compositional with the actual structure of the language, and then cross-linguistically? Answer to that is no. So these are examples that come directly from the original AMR and some of the original Chinese AMR. And this is from the Chinese AMR that I think was really interesting. This is the example that I used to convince Bert that we needed Nianwen, that we needed scope in AMR. So that was the original example that motivated our proposal for UMR in 2016. So everyone had their own earthquake. No, obviously, there's one earthquake, right? So we need to have the appropriate scope. However, look at this. I know I'm not sharing my COVID shot with you. And so there's a type token distinction, which I'm not going to pay attention to. I'm talking about the actual injection. So what's interesting is, look at what the type, I've done a type raise. I'm talking about the vaccine as the actual type, as opposed to the injection, the instance of the shot itself. They're distinct. Okay, so one takes wide scope, there is a vaccine shot, and everyone's had that shot, that same vaccine. So I can reason with that. So I can say, well, you had the Moderna vaccine from 2021, so you should be okay, right? As opposed to a specific instance of when was your shot. So the first idea is a natural default reading, and this has been discussed in the semantics literature for about 70 years. But someone didn't answer all the questions. There's this notion of introducing a polarity to the answer, and the polarity of introducing a negation doesn't speak to the scope at all. It just introduces polarity. There's some famous issues, famous phenomena. Thank you. Who's heard of neg raising? So neg raising or neg lowering goes all the way back to even before Larry Horn, but Larry Horn kind of did a nice formal treatment of this, which exists to varying degrees in different languages. If I have a negation over an attitude predicate, that I can, depending on the attitude predicate, I can lower the negation to actually get something which would be closer to the way we would want to model it in a first order epistemic logic. So Bill thinks that Mary doesn't like fish, for example, if that works. As opposed to Bill didn't say Mary was sick is not the same as Bill said that Mary was not sick. Okay, so there are reporting verbs. Usually the distinction is making clear that you do not have a across the board rule that makes a blanket reduction or lowering of this negation. We encountered this when we were creating the fact bank corpus with Rosé Sari, and her de facto algorithm had to basically be sensitive to this type of stuff. But this happened. These types of examples are really presuppositionally sensitive, and they exist in real data. We don't want to revitalize the nation through trials and tribulations. The presupposition is we do want to revitalize the nation, but not using that means. Okay, so there's a comparison set. This is pretty standard presuppositional theory, but you still have to indicate how it's going to be modeled. And just does a representation language like UMR, does it have the means to create such presuppositional content? And this is kind of a classic presupposition. He doesn't want to have dinner at the Thai restaurant. He wants to have dinner, but he wants to go to Mulan or to Panini's Pizza. So I don't want you going to the university in Europe. Okay, ditto, same thing. I want you to stay right here in the good old United States. So the idea was essentially we want to maintain the predicated core, but we also want to represent the quantified expression in a relational form with a scope node. So the original idea of a modal polarity feature, John can't afford a car at the moment. This is possible, this is modality, and I have this negation, so it is not possible. So the default interpretation of this is wide scope negation over the diamond or the modal operator possible. Within that, completely subordinated in terms of the scope of the possible, and still within the scope of the negation, is the entire predicative graph of affording. So let's take something like every student did not fail. All right. And the kind of semantics of that should also include what? What am I trying to tell you? If you're my department chair and I'm telling you about my class and I say, well, every student did not fail, what do you conclude from that? This is just an inference task. What do we conclude? Somebody passed, right?
Yes.
So, okay, so I have negation of fail for all. There's no way looking at the graph without having a specific schema of interpretation or how to put these together compositionally. So, again, as I said, it's fully possible to do that. Graph interpretation algorithms have been around for 40 years in graph algorithm interpretation in computer science, but it's not clear how it works with language. Language graphs like this are usually something like HBSG, and in HBSG you have specific modes of unification or compositionality. In a DAG, which is an AMR, it's never been proposed. There's not a solution to this. So what we did, we went back to TimeML, ISO-TimeML, in a 2019 paper at the first DMR conference, and said, we've used in the ISO family of representations, including space, quantification, but most of the time, this notion of a scope and scope relationship. So a tau covered every cookie. I want my interpretation of this that I want to convey is one tau is covering all the cookies. And so, and there's this, I have computers on every desk. I want that to be not one big computer on all the desks. That would be a 1955 computer, a really large computer covering all the desks. No, I need to distribute them cloud covered every neighborhood in the city. There's a policeman on every corner in the town, so it's not one big policeman, right? So we need to make sure we understand how to do those types of spatial relationships, and they're obvious from the obvious from the relation of the individuals and the predicate. So we introduced this idea of a scope relationship, which was for time. So basically, if I have a teacher taught every Monday, I don't want there to be a big teaching which covers every Monday in the semester. You can think of a course. There's a course that takes place every Monday for 13 weeks, but it's not the same teaching event. It's going to be this teaching event which is part and parcel of a large sequence of events structured into this course. So it's a complex object. So the way to do that would say, well, I have this relationship. I've basically turned this into an AMR, and basically saying that the teaching is going to basically fall within the scope of time. Okay, and that's the natural interpretation when it comes to a predicate and a temporal expression in the Groningen meaning bank. And in most of the AMR corpus, you've got a temporal expression or a spatial expression, and then you have the predicative core, and the default interpretation is to take the widest scope possible for the time or the space. Okay, that's in general. That's a very good default interpretation. That's for time. Time's easy, relatively. So we introduced originally this idea of scope link, and took the relation that I'm kind of pulling the arguments from, and the arguments that need to be scoped relative to each other. And the idea was that lower is broader or wider. It's essentially a linear structure, okay, kind of a pre-order. So you modify the relationship by introducing predicative domain. So you have this predicate, and I say that there's a scope of those, and the position determines the relationship in terms of how wide it is. So, for example, some person fed every dog. If I have the interpretation that we hired someone to feed all of our dogs, then their single individual is scoping the dogs. So that was a way of interpreting scoping of the one individual entity over the other relative to the predicate of feed. Okay? Utilizing the predicative core, this is in red because we don't really like it there because it's violating the AMR predicate root, predicative core principle of UMR and AMR. But what else could we do? So it works fine. You have a lot of problems that were encountered when generative linguists started doing what was called quantifier raising, and multiple quantifier raising structures like Tanya Reinhardt and other people in the 80s, where you'd get multiple quantifiers, and so you have to keep building up structure. And HPSG did the same thing. In fact, LFG, HPSG, coming out of GPSG, and all the feature-based AVM, attribute value matrix-based representations, had the same problem as GB, government binding, and subsequent generative minimalist interpretations within Chomsky models, where you keep building up structure to scope another quantifier, broader and broader and broader, so you're building up. And the idea of building up structure, in a way, is kind of odd for from a computer science perspective. So it's something that you want to try to avoid. You want to start at the top and basically say, or you start at the bottom and come up with something that you know is going to be a single type of entity, which is going to be a predicate, okay, or it is going to be a scope or whatever. But you don't want to just keep allowing for arbitrary additional binding environments. Usually, you can argue against that if you want, but that's my view. So.
Sorry, I have a question.
Yeah.
Is there a particular reason why in the predicate we have arg0 as computer, arg1 as desk, but in the scope relationship we have arg0 as a desk, but arg0...
Oh, so that, where's Julia? Okay, Alexis can answer. So be located at 91 is a specific type my favorite relation in all of UMR, where it takes a 0 and a 1. Right? So, Alexis, is that generally for state of interpretations, or?
I'm sorry, I'm not the right person to answer
So
this.
Julia would know that, right?
Yeah.
Is she here?
No, she's here.
No. Okay. But that's the idea. Okay.
I think her question is why for B located desk is at 1 while for scope it is at 0. Is that the question?
Yes.
This is R1 relative to the predicate.
Yes.
Okay.
But why in the scope? It's like a reversed.
Why not? It's arbitrary. You can do it either way.
So
This is not a choice. This is lexically dictated by the semantics of the predicate. This is an arbitrary free choice. Okay? So I say it's a choose, basically a free choice of take a scope.
So
Okay.
R1, R0 from the scope definition, they don't make any difference.
It's an ordered relationship, right? I'll see all of you for office hours. I'm going to take arbitrarily, Ifan, you're first, okay? And Bermit, you're second, okay? So it didn't have to be that way. Okay?
Oh, but I thought that has something to do with wider scope.
It does. The consequence is it's interpreted as wider scope, yes. But I'm saying you can imagine it being an arbitrary, non-deterministic choice, right? It should not be. It should be tied to our understanding of that sentence in the context. But you're bringing up a good point. It's the choice. So I look at a sentence. I say, okay, the computer's on every desk. I shouldn't really have to do a lot of reasoning about that, right? But why? How would I know? I'm just say you're a probabilistic context-free grammar doing semantic interpretation. Good old days, 2005. Okay, you have a probabilistic CKY algorithm with post-interpretation into a nice HPSG full DRT system. Okay, I saw such things running in Saarbrücken, 2005, 2010. Massive, very, very large, beautiful SDRT representations. Well, they didn't know what scope to give something. How would you know? At the time, there you have training data. You come up with some sort of best MPA. So you do some sort of probabilistic training, and you find out, well, in general, this seems to take a widest scope on blah blah blah. Right? So you still have to do supervised learning to train. What would be the clues indicating that something is wider or narrower? So in this case, we all agree, right, that a computer's on every desk means the desk is wide scope?
For every desk there is a computer.
Yeah, right. How could we encode that? The general preference, it's a really hard problem. I want to know. I mean, I have some thoughts, but I want to hear what other people think. You're not going to get it from training data, okay? It's going to have to be something, but it might come from world knowledge. So you're shaking your head. What kind of world knowledge would indicate or suggest?
It would be a massive computer. I mean, yeah, if there's a whole bunch of desks, you can't have a computer on every desk unless it's so large that it's infeasible.
So let's look at some common sense spatial schemas, okay? And I want to use these, okay? So I was talking with you yesterday about using some of the formal semantic basis to see what can we actually leverage formal semantics and formal ontology to make sense of general common sense inferencing. So if something's smaller than something else, and then I impose quantificational ordering, see if that works.
So container-content relation.
Container, containee, really, exactly. Genau. Right. And I think it's worth thinking about that. And in fact, it's very easy to start playing around with that in terms of in-context training for LLMs. Try it out. Use it as, first off, you can use it as prompting, okay? Then, as Yang Yang and others in my group can tell, you could perhaps come up with a knowledge database and use it as a RAG along with some in-context learning and say, what do I get as a result? What are the results of assuming that particular axiom? Right? Container-containee relationships will provide for the following scope order. Right? Let's try it out. Interesting. That's what we need to do. You're not going to get the data from the you're not going to get enough training data for that. Any other questions? Yeah.
Is this in part because maybe in comparison to some other kinds of ambiguity, scopal ambiguity, there's something that we usually mean, like there's something that we usually prefer as being the logical or common sense interpretation.
So I do think that so let's do, what I would do is this okay if we pursue this kind of line? I'm missing out on some time, but that's right. This is really good stuff to think about. I don't know about my teaching material is good stuff, but the topic is good. And what I mean by this is what you do if you're a typical kind of linguist, you start varying the predicate and you varying the objects. So swap out one and put another thing. So take something bigger than a computer, all right? Something smaller than a desk. So a computer is on every marble, okay? Some things are just going to not be realistic, okay? A computer is on every plate. So imagine what the scenario would be, right? Okay, so a tablecloth is covering every plate, okay? That has logical ambiguity. There's a syntactic logical ambiguity to the scope. We know that the preferred interpretation would be the one tablecloth. Or you put it into a passive, or every plate is under a tablecloth. All right, there. No passive, should also have the same ambiguity. It does have the same ambiguity, but it has the same preferred interpretation. Okay, so I think spatial container relationships provide a very strong conceptual bias. Why is that? I think it's actually conceptually for human interpretation, for non-artificial interpretations, we've already done a prior bias in our vector space for how we're actually doing the composition. We've already created that prior. And it's certainly vector. It's vector based. It's just in our neural network. Yeah.
You have an example in the earlier slides saying something like he can't afford something, but the graph has a possible at the very top and corner.
That's the can.
Yes. Is that possible also part of the scope?
There's so many things wrong with the possible in AMR and by virtue of inheriting it UMR that I don't want to go there. There's so many interpretations of can as coming from any language, whether it's deontic, whether it's alethic, whether it's epistemic, whether it's doxastic. That's one issue. Your issue was another question though. What? The negation or?
Yes.
Okay. I'll get to that. Can we move on? So the solution we came up with. So this is the basic syntax. If we look at, so what we did in that paper was just, okay, let's just assume we have what we have. We have an AMR tree. Let's see if we can come up with a deterministic, relatively, interpretation. Walk the tree and get an interpretation. So that is going to give me something like that. That would give me something like that. Okay? And it is truly the case that in natural speech, does not always have wide scope negation over the modality. The way of doing narrow would be to put the polarity in the predicate for sure. Okay. So this has nothing to do with any kind of quantification of an individual outside of this, by the way. So any Barkhan formulas, you probably don't know what Barkhan formulas are, but Barkhan keep going through colors. So if I can say necessarily there is some X phi, then I can say there is some x which is necessarily phi. So the ability to look at my space of possible worlds, and by virtue of having there be this modal operator, pull out an individual and say, oh, that individual exists, as opposed to exists in this intentional world. But we're not even going there. That does exist. We need to do that. This is not a trivial thing. This is not just for logicians. When we reason about graphs, you don't want everything to be subordinated to a modality. This is absolutely critical. If you're doing point of view, you're doing framing. Okay, so Jen here, her student is framing. If you're doing any type of perspective taking, where you're taking a modality and you're saying, well, I don't agree with that, or something like that, you need to pull out what you want, what you need to, from the modality, from the intentional component that you're considering iffy or questionable, and extensionalize what you can. Always extensionalize. So you're going to pull out proper names, definite descriptions, locations, whatever else might be. And what is being dubiously referred to in the modality is how you're characterizing what happened. Well, it was an attack. No, it was a liberation, or whatever it might be, right? But the fact is, I've got two named entities that did participate in them, namely entity 1 and entity 2, and how they interacted is what's under discussion, right? That's important. How do we do that in UMR? Well, there are plenty of ways of doing that. We do extensionalization. And there's really very efficient graph algorithms for doing that. Okay, here's John can't afford the car at the moment again. So now here's what we did. Introduce a scope node. Okay? And I showed that before, but this is the AMR linearization of it. And we have the pred, so it's three arguments, right? There's the pred, and then the arguments which are implicated. And this is just the negation, and this is the specific argument of the pred. So this is going to be, it is not possible. So, okay. So here's how it's implicated, or here's how it's illustrated in a graph. Now, problem with this, it doesn't provide a direct compositional semantic interpretation of the graph associated with the sentence. You still need a special kind of interpretive mechanism. And it also introduces this non-predicative root, which is okay, but it's contrary to the general spirit of UMR. So you can live with that. But there's actually a solution already waiting in the syntax, the syntactic sugar from the original AMR, which is to use the arg-of relationship and apply that to pred and pred of. So push the scope node under the usual root node of the verb as the value of pred of. And you can just have the root still stay as the root. So the way that works is someone didn't answer all the questions. And we have, you're saving the cookies, right? Okay, good. I have the answering with the person and the questions, with all. And then I've got, so answer has as its dominating node, it's the value of pred to scope, okay? So it's kind of like, taking basically like the arg-of relationship. It's kind of like a relative clause. So answer whose pred, that is the pred of the scope with arg0 and arg1, okay? And that works out really nicely. So John can't afford a car at the moment, and that's basically, now we look at it as a pred of, and we get this, and this basically gets us this potential interpretation. So there's a lot of stuff that we need to think about when we're doing annotation for quantification, and we're just now in the phase of actually annotating the scope distinctions in a larger scale experiment. It's really hard to get this type of annotation done. It usually takes someone besides just interpreters, so you need to have trained linguists for annotation. Now, however, the goal would be to use LLMs as an assistant. So one thing that would be interesting would be, and oh, Bert's here. Hi, Bert. Would be to see how we can use LLMs to help in the creation of annotations for the data. Who was going to send us the data for the quantification from Colorado? Was Martha going to do that? Yeah. Okay. So I think there's more than a master's, it's possible, certainly a good master's program, but possibly a PhD thesis, which is the kind of interaction for LLM annotation for something that is as sophisticated as relational scoping type interpretation. One thing that we don't look at is distributivity and collectivity. So 3 people carried 4 pianos upstairs, the classic examples. That's not touched on by this particular interpretation, this particular reading. Okay, so now I have 25 minutes. I want to quickly go into a representation which is going to be using a compositional treatment called continuations. And I'll go over that pretty quickly because I actually want to focus on some of the sub-event structure representation, which has immediate consequences and utility for inference in AI agents and LLMs. And we're already using it for state tracking. Oh, Kay left. Kim is one of the people using that in his dissertation. So continuation, who's familiar with continuations in computer science or in linguistics? Continuation is the rest of the meaning of an expression in the context that it's used. So it has been around in computer science since the 1980s. Chris Barker and in the paper Barker and Chan started developing how there's a relationship between Montague's original interpretation back in 1968 of the meaning of a noun phrase or even a proper name as a set of properties associated with it, a set of attributes, if you will. And that was called type lifting. So John, as a name, is a type E, but I can lift it to a generalized quantifier, which is the set of predicates associated with John, right? So that kind of embellishing the environment of John is called a continuation. I'm basically telling you what you can do with John. John's still an individual, but John can participate in all kinds of predicates, specifically the set of predicates, and I can pick one particular predicate. And it's used in programming language. Every modern programming language has a way of handling continuations. It's effectively a compositional way of handling go-to statements. That's what it is. It's a very, very, very elegant encoding strategy. There's another, so if I was asking about gesture and the meaning of a gesture in context, there's also a continuation. I'll go into examples here. So if I say that, okay, we went through that. We went through those 3 gestures. The second gesture has a continuation in it. I'm saying you're going to move something, but I don't know where. I'm listening to you or I'm watching you, and I don't know where you want me to move something. So I have to have stored with me the rest of the computation that I need to apply that to, which is going to be, well, where am I going to put it? First off, you're doing co-reference to what I just gestured. Okay, so I'm sucking in prior context. Okay, that thing. So I'm going to plug it into the move. But move is going to be move X to Y. from whatever, let's say it's a 2 plus. Take a verb net representation of move, okay? So the y is not expressed by that. It's coming later. So the later value, the thing that allows me to plug in the later, when I say there, is in the continuation. So that's what a continuation is for. It's a wait for it, you're going to get the information, and then you get it, okay? You get the idea? Does that answer your question, Yvonne? Okay. So, low battery. Does anyone have a charger?
I can
You don't mind? Thank you very much. So continuation is the set of contexts that when you put them together, it's going to result in a sentence, a true sentence, or whatever type you want it to return. Okay, in programming, it could return an integer, whatever you're trying to compute. So I have arg0 about a dog barked. Okay. So we have the meaning of dog. What is its continuation? Well, we know that it's the arg0 of something. So let's say arg0 mn, where basically it's going to be this set of continuations, and the continuation is going to be this relationship between two continuations. I'll get to it in detail here. Basically, I know what to do. I want to basically give a context of what I can do with a dog. So in a generalized quantifier interpretation, in Montague, I'm writing here, I'm assuming you can see, it's very, very dark here. Oh, thank you so much. Thank you. John is of type E, and John's a man. A man is going to be a set of predicates, but I can think of John. So how do I say that? Well, there's this set of predicates. So set of predicates. So lambda is just set of predicates existentializing one of the anchor properties and leaving open the second. So what the generalized quantifier interpretation of a man does, that's the denotation of man. And first time you see that in semantics, you go, what in the world is that? And then you look at an operational and you go, oh, that's pretty cool. I'm basically kind of waiting around for me to basically plug in some property to interact with man. So a man walked, along comes walk, and basically I have a man walked, which is just basically the lambda conversion. I'm not going to go into the semantics of that because you probably know it. And something like that. But the point about Montague's theory was John can also be seen as the set of predicates, oh, that's better, implicating John. So John can be seen as raised to this type, which is the set of properties that John has, okay? And so that way, they was solved. This was brought up because of the quantifier distinction of John and every one of his students. I need to be able to coordinate those together and do a conjunction of those with like types. So they're all the same type, which is ETT. This one here. Okay, enough of that. Now, that's a continuation. This is the continuation of John, the P. And this expression is called a continuized expression for John. So I've got John, the normal form of John is just, it's a type, E, and it just means John. And the continuized form of John, which is usually got a bar over it, is ETT. Okay? So far so good? Means, here's what I can do with you, John. So now, what Barker and Sean said, everything in the language can be continuized. Let's just make everything kind of quote-unquote generalized quantifier. So bark has a continuation, dog has a continuation, everything has a continuation, a sentence has a continuation. For bark, it's basically, you have an expression, okay? And I want to look at this. Okay, I've got a semantics for this. And then the continuation is going to be everything else, the complement of me in the sentence. Okay? So, and then I have to basically plug in the way I'm representing the thing I'm continuizing as a variable in that expression. So how can I be used in the expression around me? All right? Now, I don't want to get too confusing here if I get into the real details, because we only have 15 minutes left. But the point about this is it gives you a compositional approach to doing scope with the way I was just talking about scope. Okay? And walking through it, and you can go to the paper that I'll send you the paper. It's a 2020 paper with Ken and Lucia Donatello. We have a really, I think, a pretty reasonable treatment of this for most quantification and negation and modality. Okay, so now you can reverse the scope with this using the scope of the pred of relationship and so on and so forth. Derivation is really too complicated to go into right now to give it any serious consideration with you to really understand it. If you want to talk about this tomorrow sometime, I could have a special office hours. I do want you to understand this. But the point is that because of the way the UMR is structured as a graph, that is not a hindrance to having a formal interpretation that can make it compositional. It's just a matter of what are the underlying elements, base elements, like they have to have enough time, temporal operations, they have to have enough, there needs to be expressive components to it. And then you just need to work on the compositionality. Okay, now, hopefully that wasn't too scattered, because I want to get to the idea of going from AMR and with it, sometimes to UMR, which is not hard, to understanding the sub-eventual representations of predicates, which I've been working on for a number of decades. Kind of a sub-eventual Davidsonian representation. And that's absolutely, I think, critical for understanding the way situations change and the dynamics of discourse and everyday interactions. So VerbNet is what we started off with. And we took a dynamic event model where events are built up from multiple layers of primitive constraints on individual participants. And you can have changes taking place within one event, but not another event, when viewed at a subatomic level. So starting off with this work that I did with Jessica Moskowitz, a PhD student of mine, but developed considerably more, and now coming out next year in a book with Elizabeth Jezik, you distinguish between formulas and programs, propositions and transitions. Okay, that's the basic idea. And basically, within a state, you have a set of formulas, and then what transitions you to another state is a program. Okay, and they're the functions that take you from being open to being closed if you're a door, from being full to being empty after drinking. And so the program composition is very straightforward. It's something called a first-order dynamic logic, and it's very well studied in computer science. And it's got a very nice very simple semantics, roughly. If you keep it propositional in first order, you can have a limited first-order semantics, which is very, very clean. So basically, you can say alpha happens, then beta happens. You can iterate them. I have primitive actions such as slide, 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 slide. Just iterate. You can have or. You can turn programs into formulas. So this is basically saying every application of alpha of drinking will give you an empty glass. and this is an existential. It says there is an application of pushing where the door is closed, or something like that, okay? And you can also test. You could say, are we there yet? This is what the child does in the back seat when you're driving to Disney World. You know, are we there yet? Are we there yet? Are we there yet? And then you have the negation and you've satisfied. Okay? So that gives you a basic opposition structure, which is called an achievement in Wendlerian semantics. So you get this basic Wendlerian diagram. You have a state, you have a process, you have a simple transition, open and close, and then you can combine these to get something like building something iteratively to give you a new thing. Okay, now, why is this important? Well, what we started around 2018 and finished around 2020 was with Susan Brown and Martha Palmer and a lot of their graduate students at Boulder, was to go through the entire VerbNet set of classes and modify the semantic component, which was not really very systematic, and plug in a GL, generative lexicon semantics, to the events. And so if you go to any site, any verb, and you look in what you'll see, you get obviously the dependency structure, but the interesting thing here is the semantics. So what you have a lot here, okay? You have what's called the syntactic frame file, okay? And these are the constructions associated with the specific lemma, a prop bank lemma. So this is a really important lexical resource for anything you're doing. If you're doing parsing, if you're doing LLM prompting, whatever. And so you have the participant roles, the semantic roles associated with it. And then you have kind of GL sub-event structure, such that you're doing some stuff at the beginning of the doing. There's no such thing that I can call the product because I'm building it there. It's not there yet. And I'm doing something. I'm working on something which is going to be the material for it, which may or may not be mentioned, because that's why it's optional. So you don't necessarily, I'm building a house out of wood. You might just say I'm building a house. But there's always an implicated hidden argument of there being material. And then at the result, you have a product. So that's the kind of general idea behind that. And we wanted to show, can we represent that as a UMR or an AMR? So given the event structure and the pred, we thought, well, let's have an event structure be a component of the pred, and we'll have sub-structures to that, and then we would index the sub-events. So here's pour them into the bowl. I've got this location in 2 different locations. So you pour them into the bowl. I have an event structure of something being not in the bowl and being in the bowl. It's a very trivial example. But notice that the addition of the sub-events was actually not at all taxing or difficult. Introducing essentially a first-order representation of the events, it works fine in terms of it doesn't violate any of the general principles of UMR or NAMR, and essentially is also not doing any type of destructive operation over the existing AMR or UMR representation. So essentially the idea then is you use a negation to represent an opposition structure from going from uncooked to cooked, or unsliced to slice if you're slicing onions, or shut to door, unshut to shut for a door, whatever it might be in terms of oppositions. Now the reason this is important is when we're updating information in the context of dialogue, we are changing the environment as well as our epistemic attitude towards the environment. So we need a way of graphically representing that aligns with my belief about something. So you put something on the table, and so put the block on the table. The result of that is the block is on the table. And so that's part of the propositional content of the result of your action. So that's now part of our common ground. Okay, so I believe that because I saw it. So this is a way of enabling that to be a representation. So I don't believe only that you put the block on the table. The important thing is the result of the putting. Okay? And that's what's called result-based reasoning. So, just to cut to the chase, I'll just show you the overall representation. This is what the resulting glamour looks like, the GL-AMR. I maintain the original AMR representation. I have an additional edge, which is the event structure, which has its sub-events. And these will be reentrant to potential objects here. And these will give you the oppositional structures or states. And these also come directly from VerbNet propping. We don't have to introduce any new sub-event properties. And so that is something that has been really useful for helping us do inferencing over procedural texts as well as non-procedural texts when trying to enhance the inferential and knowledge capabilities of LLMs. And here's, for example, a creation for bake, and so on and so forth. You get the basic idea, right? So this is the takeaway here. This is a way of procedure. What have we done? We have gone and, as it were, mined some of the semantics literature, the resources available in the semantics literature. So you have a language resource, you have a semantic resource. The semantic resource here was a rich, sub-eventual theoretical device, an artifact, GL's sub-event representation. You could take Bill Croft's force dynamics and do the same thing squarely in UMR. You could do any number of other types of models. But the point is, UMR is generic enough to allow that if you respect the constraints that allow you to do reentrancy and co-reference in the equational structure of the template. The benefit is you're enhancing the expressive capabilities of the language, okay? And in a way, when we go and modify the guideline and specification for UMR, we can say, let's just take in the specification from the GL sub-event structure and we'll just do an adaptation or a modification of it squarely, okay? And it's coming kind of as a plug-in and not necessarily built into the guideline as a new object, okay? What else would lend itself to that? Well, already, did Julia talk about spatial AMR? You know, the spatial AMR. So there's a component, a very well worked out sub-language for AMR on spatial relations, which can be modified to UMR. That can also have the same type of modification and insertion into the UMR family as well. Okay? So, let me just see what else I have. Now, the final thing I want to mention here, just in the interest of time, I mentioned when Andy and I were talking about gesture that UMR is broadly construed by us as being a representation language for communicated acts. And I went through that hierarchy of gaze and attention and posture and facial expressions and actions. So one of the things that is associated with this is poor, and poor is just the UMR. This doesn't tell you where it came from as a modality. So I might have an iconic gesture, which is poor. So I want you to take this and poor, right? So I don't have the actual object. So I say take that and take that, which is a cup, and I do the affordance grasp, and I want you to pour it into it, okay? So what is the gesture associated with that? Well, the content in the gesture, which is arg1, right, that we went through in Gamma, would actually point to the VerbNet, and in this case, the Glamour VerbNet, prop bank sense pour 01. Now, it's important to know that the consequences of that would be that the liquid is now in the location of the cup, okay? And that's actually coming from an action annotation that we're actually working on identifying automatically from doing action recognition using, those are 2D, right? 2D neural nets. The interpretation of that 2D neural net token is converted to a rich symbolic embedding of this. Okay, it's not just a neural net token of whatever. It's enriched in a kind of in our neurosymbolic pipeline to have much more power for doing inference. On that, I think I'm going to close because it's time for lunch and we're out of time. There are so many issues open to semantics. As I was talking to people yesterday in office hours, and as I mentioned, that it's an entire Estley summer school that is something I want to do for next year. But there's so many other things that are just waiting to be handled. I'll stop there, take questions. What is your thought in terms of the big gaps in UMR in terms of semantic representation, which might actually be implicated by there not being a syntactic representation? Any thoughts? So first off, thank you. I'll stop there. And then we can take some quick questions. Everyone's too hungry. We will revisit this tomorrow, okay? So let's get lunch, go to Boston, and I'll see you guys tomorrow. Yeah, free.
Related now to these sub-events, then in terms of aspect, you also label them or just the main event?
So that's a very good question in terms of the UMR annotation of aspect has not been extended to the sub-event representation. GL has its own interpretation of how to do aspect given sub-event structure, as do several other people, right? There's quite a few formal models for doing that. Lucas, Champignon, and other people. I think we would have to probably say that the aspect is a root property